A vector is given to you and you are asked to prove that the given vector creates an irrotational field, and also you have to find out the value of scalar potential. Suppose the given vector A is creating an irrotational field, it should satisfy the condition of del cross A equal to 0. If this condition is satisfied, then the field created by the vector A is irrotational. If it is true, then the nature of the vector A should equal gradient of a scalar. Here pi is a scalar potential. According to the identity of vector analysis, if curl of a vector equal to 0, then the vector should equal gradient of a scalar. Del cross grade pi equal to 0. From these two conditions, we may get an idea the vector A should equal gradient of a scalar function. Now we have to prove curl of the given vector equal to 0 and the value of scalar potential pi. First we take the value of curl A, del cross A I j k dou by dou x dou by dou y dou by dou z. This is determinant. Now we have to put the coefficients of I, j and k. Here the coefficient of I is x square plus x y square. This is the coefficient of I. Coefficient of j is y square plus x square y. Coefficient of k is 0. No k term is present in the given vector. Take the determinant value. This is equal to I into dou by dou of 0 minus dou by dou z of y square plus x square y minus j into dou by x of 0 minus dou by dou z of x square plus xy square plus k into dou by dou x of y square plus x square y minus dou by dou y of x square plus x y square. Dou by dou y of 0, this is 0. Dou by dou z of y square plus x square y is also 0 because these two terms are free from z. This value is 0, this is also 0 because these two terms are free from z. Therefore, this is equal to k into dou by dou x of y square 0, dou by dou x of x square y is 2xy minus dou by dou y of x square is 0, dou by dou y of xy square is 2yx. This is also 0. 2xy minus 2yx equal to 0. Therefore, del cross A equal to 0. Now we have proved that the vector A creates an irrotational field since curl of the given vector equal to 0. Now we have to find out the value of the scalar potential pi. According to the identity, if curl of a vector equal to 0, then the vector should equal gradient of a scalar function. Vector A should equal gradient of the scalar function pi. Then A vector should equal I into dou by dou x plus j into dou by dou y plus k into dou by dou z. This is allowed to operate on pi. This is grade pi. This is gradient operator into pi. Vector A should equal I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now substitute the value of A in the above equation. X square plus xy square I plus y square plus x square y into j. This should equal I into dou pi by dou x plus j into dou pi by dou y plus k into dou pi by dou z. Now we have to equate the coefficients of I, j and k. If you equate the coefficient of I, this is the coefficient of I, here dou pi by dou x, dou pi by dou x, which is equal to x square plus xy square. This is equation 1. Then coefficient of j is dou pi by dou y equal to y square plus x square y. This is equation 2. Then coefficient of z that is dou pi by dou z. Coefficient of k is 0. So dou pi by dou z equal to 0. This is equation 3. Coefficient of I is here dou pi by dou x. In this side x square plus xy square. Coefficient of j here is dou pi by dou y. In this side y square plus x square y. Then coefficient of k in this side is dou pi by dou z. The left hand side is 0. So you may get 3 equations. Now differentiate, integrate equation 1 partially with respect to x and keeping y and z as constants, we can get pi equal to x cube by 3 plus x square y square by 2. See, this is equation number 4. Integral of x square is x cube by 3. Integral of x is x square by 2. This y square is a constant. We have written as such. In addition to this, we have to add a constant of integration plus pi 1 of y comma z. Keep this equation 4. In the same way, integrate equation 2 partially with respect to y and keeping x and z as constants. You can get a new equation, that is pi equal to y cube by 3 plus x square y square by 2 plus constant of integration pi 2 of x comma z. This constant should free from y. Just we have to integrate this equation with respect to y. Pi equal to y cube by 3. Then x square is a constant plus x square. If we integrate y, we can get y square by 2. So this is now come to this equation 3. Integrate equation 3 with respect to z and keeping x and y as constants. You can get pi equal to pi 3 of x comma y. See here, if you integrate this, we can get a constant term alone because differentiation of a constant equal to 0. If you integrate this equation, you can get only the constant term pi 3 of x comma y. Now you should write the values of pi 1, pi 2, pi 3. Pi 1 of y comma z equal to terms of pi independent of x, that is equal to, say, this is a function of x, this term is also function of x, but this term is free from the function of x, but this term is the function of x, so which is equal to y3 by 3. This is the only term present in pi independent of x. Then pi 2 of x comma z equal to terms of pi independent of y. See, this term is independent of y, but this is the function of y, this is also the function of y, this term is also having the y term. Therefore, this is x3 by 3. So pi 3 of x comma y equal to terms of pi independent of z. See here, this term is independent of z, this is also independent of z, this is also independent of z, this is also independent of z. These terms are present 2 times, so that you have to take only one time. This is equal to x cube by 3 plus y cube by 3 plus x square y square by 2. Therefore, the value of pi equal to x cube by 3 plus y cube by 3 plus x square y square by 2. This is the value of scalar potential. If the given vector curl of A equal to 0, then A equal to grade pi. Then the value of pi, the scalar potential, is x cube by 3 plus y cube by 3 plus x square y square by 2.